Okay, today I'm going to see if I could do a walkthrough, talk through on the Demco Demon 750. Pretty much no information on the net for it, no schematics. So basically I got my hands on one, and I did a reverse engineered blow up schematic there. Changed the stuff to match, what I found in this Demco Demon 750 amplifier, and gonna do a walkthrough, talk through in it. I already did a bench power up on the thing, and this thing is swing to 1,000 peak. Basically, the Demco 500 is a two baldies driving 12-pin 6LF6 type tubes, and then the Demco 750, instead of two driving 4, is 3 baldies driving 6LF6 type or family tubes. The schematic shows 6LR6, which is a family or cousin of the 6LF6. Pretty much the same specs as the 6LF6. So here's the differences I found. First, I'm going to start with all that section there. Pretty much everything in the screen or the picture is preamp. That's your preamp and circuitry. Over here is your preamp relay. That's your tuning coil to tune in your preamp. That's your preamp amplifying transistor. That's a little signal diode in the preamp. And by the way, usually when a preamp goes, it's usually the transistor, sometimes the diode, sometimes both, and then once in a while it will be the relay itself. It's got bad or dirty contacts, but most of the time it's the amplifying transistor and or the diode there. And most of the time the reason they go is people put in too much power running through the amp, even in standby. So that's the preamp circuit. For the schematics, it's the same for the 500 and the 750. They didn't change the preamp at all. And over here in the amp, that cube box relay right there is the preamp only relay, and that octal type plug there is the main power relay. I don't like running relays through a plug-in plug. You lose power that way. But anyway, they did it, out of convenience, but I don't like doing that. But that's your preamp relay right there. And that terminal strip right there is your preamp circuitry. That's the transistor in that silver can there, your preamp transistor. That's your preamp tuning coil right there. And that's the rest of the circuitry, all for the preamp on that power strip there. If you wanted to bypass, you could take all that out and take the relay out and bypass it, and then you just wouldn't have a preamp. Actually, it's actually a pretty good preamp with the tuner in it for an amplifier, but then again, all preamps and amplifiers suck. They bring in more noise than anything else. But with that said, it's still a decent one, fair for as far as the preamp goes. So that's that circuitry. That's just the preamp relay. Trying to get it in the box there. All that is your keying circuit and your main relay there. Let's see if I can find a pointer. That's your keying transistor. When the relays won't key up, your keying relay, it's usually that and or the diode there that goes through it. Especially with the keying circuit transistor and diode, what happens is people run too much power on the input of them, and that's the input. It's got a small value cap. This one is 27 picofarads. That's what I call a little sniffer. So it picks off, maybe half a volt or so from your watts coming in, it picks off maybe half a volt, runs it through the diode, and then runs it into the keying amplifier, right? And when that diode, when it sniffs the power coming in, that diode rectifies it, and then that puts it on the base of the transistor, and the transistor activates, and it basically grounds the relay over there. And again, most of the time it's not the relay that sticks or doesn't work. It's usually the keying transistor leaks, and or the diode is bad or has shorted. That's your SSB delay capacitor. It just switches in a capacitor that holds the relay down for, approximately a second, half second, whatever the time delay is on SSB. That's your coil for your keying relay. The power comes in on this side. That's your low voltage coming in, goes through the standby switch. So no power is applied during standby. You turn the standby on, you got positive over here, and you got the negative side going to the transistor, and it's only activated. This transistor is only activated and grounds it when it sees power coming in from the input side. And most of your problems are going to be the keying relay and the diode. Nothing special about that circuit there in the Demco Demon 500, 750, or any of them. Over here is your contacts for the keying relay. All these are just the contacts of it. So that's simple stuff. Nothing fancy there. Nothing really fancy about this amp. One thing that's a big difference between the Demco 500 and the 750 is the 500 has two transformers, a high voltage and a filament / low voltage transformer. They use this for both. They use the small transformer for filament and low voltage, whereas the 750 has three transformers. You got the same high voltage, you got a bigger filament transformer to handle, all the extra tubes in the 750, and then you got a separate low voltage and bias transformer over here. The 500s does not have a separate bias, or it doesn't have any bias transformer. It just uses dropping resistors in the grid, whereas the 750 has negative bias. The diode pointed negative here, then a filter cap here, and that's the negative bias coming off the low voltage transformer. This is a 24 volt transformer, so you got approximately 33 volts negative coming over here for the negative bias, right? And then that negative bias only goes to the finals. It's connected up here and goes to the final, the final tubes, pin 5, grid 1 of the final tubes. So the 500 doesn't have that, so that's something to be aware of. That's not in the schematics at all on the 500 for that. They just use dropping resistor. Okay. Also on the low voltage transformer, that's how you get the low voltage. It's a center tap on the low voltage transformer, and it just goes to the low voltage power supply, a diode facing positive, a load resistor, filter cap, then it goes through the standby transmit switch, whereas when you're in standby, no voltage is applied to the preamp or the key up relay, but you put it in operator, and then the low voltage is applied to both the key up circuit and the preamp circuit, right? Simple stuff. Filament transformer on it only drives the filaments. Filament transformer, this is representatives of one of the tubes, one of the drivers, and one of the finals, but it drives all of them. And that's all the filament transformer does on this, is light up the filaments. Over here you got the AC side with the fan and the power light. That's all that is. So moving right along, high voltage transformer is fused here, and it's a low tap, high voltage, and a high power tap. And the low voltage and high voltage tap go over here to the low, medium, and high switch. And on high is connected to the high voltage tap, and on medium low the high voltage is connected to the low voltage tap, and then it goes back down to your bridge diode over here. So one side goes to the fusing right in, and then the low voltage high voltage goes up to the rotary switch here, and then back down to the bridge rectifier. The ground side of the bridge rectifier goes over and into the key up relay. So it basically only grounds this high voltage diodes bridge circuit when you key down. It's kind of like the Palomar with that safety relay where you only key it down, you only activate the high voltage when you key it down through the relay, but the Palomar uses a separate relay. This goes through the main relay, but it's on the low side. It's on the ground side. So it's not high voltage going through there, it's grounded. That's a good idea. That's the way to do it, actually, is to use the ground side like they do this one. That when the key up relay keys down, it grounds the high voltage. Over here is the high voltage out when it's all grounded. Just a filter cap for getting RF off of there. And that's your high voltage capacitor bank. Uses 2 banks of 3 caps. These 500 used 60 UF caps each, whereas the 750 uses 100 UF caps, 6 100 UF caps, 2 banks of 3 in series. Okay, those are your bleeder / equalizing resistors, and that's your next to the cap there, right? I replaced the 2 banks and used modern snap-in capacitors. That's a Mako board I got from Nomad. He sells the a Mako board that works great, so I could use those snap-ins. And then that's your equalizing / bleeder resistors right there. One thing on your diodes, these old school amps had like an equalizing resistor across the diodes. That's the equalizing resistors there. That's no longer in vogue. The diodes, the back voltage is so high and so equal already. You know, with modern manufacturing techniques, with modern diodes, you don't need those anymore. They're pretty much useless. But back in the day, before they made diodes, you know, really consistent and really well with the back voltage and all that, they would help, but not anymore. So moving right along, let's go to the input. It's got a tune input right here. That's your variable capacitor for the tuner, your coil. And then that's a fixed capacitor for the load. That would be tune, that would be load. That's your coil there. And just because you don't see a tuner for something doesn't mean that it doesn't have them. It's just fixed in a lot of amps, right? So that one's a variable and that one is fixed. And over here, that's your variable cap, that's your coil. I don't see the fixed cap in there. I don't think it's that one. I think that's a blocking cap, but it's probably in there somewhere. Okay, so that's your input tuner right there. You would tune that for a low input SWR. It's a screwdriver adjustment and a hole on the other side of the amp. Let's see if I can rotate it around. No, I'm too blocked in. I can't rotate it around to see that. But anyway, that's that circuit. Then that goes into your driver tubes here. On this amp is 3 baldies that input goes to. And is mostly grounded grid, but they take grid 1, which is pin 2 there, and they run it through some resistors to get some bias on it, some negative bias, using these dropping resistors. A true grounded grid, they would just directly ground all the grids like they do on grid 2 and grid 3 here. But to cut down that gain a little bit, to tame them down, and to create a low, medium, and high side, they use different resistances to cut that power down a little bit, and put in a lot of resistance on the low, medium resistance on medium, and a low resistance on high, through that low, medium, and high switch again. And then over here, this is your super mod switch or your mod switch, and it just basically runs a capacitor across that resistor, so it keeps the resistor more stable. And when your modulation goes to swing up, or your signal goes to swing up, if you didn't have that capacitor across there, the resistor would drop voltage, accordingly. But that capacitor keeps it stable, so it will create more swing and a more stable bias with that capacitor across there for your mod switch. And then basically your output, that's the high voltage coming in. That's the coil to let the high voltage come through and keep the RF from going back. So your RF is going to go through that blocking cap. Then your basically your tune and load for the driver, which is on the front of the amp, and then that goes up and into the cathode of your final tubes there. And then going to the final tubes, they're similar to your driver tubes. The second and third grid are grounded, but it's very different on grid 1 than the 500. The 500 has another scheme similar to this, using dropping resistors for low, medium, high. However, on the 750, they did not do that. They eliminated that, the dropping resistors, and they used the fixed negative bias. Remember that transformer I said, the low voltage one that is a double, on that one? Your negative bias again goes through that diode, that capacitor is pointed all negatively, and the negative bias goes up here, and it goes to grid 1 of the final tubes. So they're, not quite grounded grids. You got your negative bias going through there. The rest is basic, stuff, parasitic suppressor, tune and load for your final. Got that safety choke there, that as if this blocking cap shorts out, because at that blocking cap you got the high voltage and the RF all meeting there, and it blocks the high voltage but lets the RF go through. But it's a lot of power going through these things, and sometimes that cap will short out. And if that cap short out, you could have your high voltage going through your line, through your relay, and into your antenna, and maybe into you, and it's dangerous, could kill you in an amp like this. So this safety choke catches the high voltage. If that cap goes, the high voltage will be shorted to ground. But these coils like these are invisible to RF, so the RF just goes right by, but DC high voltage would be shorted out by that. Basic simple stuff. The schematic is really weird on the 500 plus. Over in this area, you can see I whited a lot of stuff out. It has some extra low, medium, and high dropping resistors that are not in the 750 at all. And somebody said that went to the meter. No, it does not. Here, the meter adjustment pot, dropping resistor, and the meter is grounded, and that's been verified, on the amplifier. I even forgot where that was, but I went through it and verified it. And basically, this schematic I drew up is basically a what we got in the Demco 750. The final tubes got fixed negative bias on grid 1, pin 5. You got variable capacitor bias on grid 1, which is pin 2 of the baldies. Other than that, it's basically a grounded grid amp. Tune input, decent preamp, but I don't like preamps in amps anyway. Keying circuit, separate high voltage power supply that is grounded on the ground side of your bridge when the relay keys up. High low tap of the high voltage transformer, filament transformer, low voltage transformer, 2 banks of power supply caps. Not that hard when you break it down, you know, section to section. But if you look at that schematic as a whole, you know, it can be pretty intimidating and confusing to people. Anyway, that's it for this one. Bye.